we don't have enough length for the power cord.
Or maybe you can put the chair and then put it so high.
Well, this will have some architectural side effects.
Okay.
I'd like to avoid them.
Plug it from there and get it here.
No, it's not plugged in.
Alex, I think he has a good idea. I think the cable is long. What do you think?
Well, let's give it a try.
I will take care of this.
Okay.
One of the California.
But do we see anything interesting here?
Where are you going to stand?
I think I'm going to stand somewhere here. Can somebody tell me if the picture is right?
Perfect, I think.
Yeah? Okay.
Cool.
Of
course.
So let me give you some analogies that will hopefully make it clear why network stacks are such a good idea. And the analogy will be the human brain. So when I talk to you, I have an idea somewhere in my mind which I have to transfer to you. So this is me. This is my idea. Between us, there is a channel through which the signal propagates. And then somewhere on this other end, there is a group of people, and my objective is to make it such that this idea and idea prime have to be identical. So this is the ideal case. How does this work? So an idea is an abstract thing. Have you ever seen an idea? Yeah, I was expecting you to say no or do this, because you can't see it because it's abstract. Every time I say something, I have to transform the idea first. So what do? I take the idea, and then I come up with some words. So I transform it in words. And then I have to pronounce these words with my mouth and body language and my facial expressions. All of these instruments I use to express that idea into some kind of a signal. So that's the signal. But how does the signal come to the channel? When I talk to you, you don't see words, right? It's not words that travel through the air. What actually happens is there is a sound wave, which then is perceived by your ear, which is then somehow converted, and then at some point you get this idea on the other end. So the words have to be transformed into, let's say, sound waves. This is not a direct transformation, because somewhere there have to be some intermediate steps. For example, a part of my body has to send signals to the vocal cords such that they move at precisely the right time in a precisely specified configuration, such that the sound waves have the right form. Because if this signal is not sent correctly, you will hear something which your ear would not necessarily perceive as human language. So if you look at this transition, we begin with something abstract. And as we go down in the process, we turn this into something concrete. So that's one important property you have to keep in mind. That abstraction grows in one direction and decreases in the other. Another important concept you have to keep in mind when thinking about network stacks is the option to recycle technologies. For example, let's go back to this illustration. I have an idea. I express it into words. Right now, I'm expressing it in such a way that you hear English. So at one of these intermediate stages, there is some kind of a function or some kind of a black box in my brain or in my organism which takes this and transforms it into that. And that then becomes a sound wave. If I chose to speak in Russian, I would say something like «Раз, два, три, тест». Понимаете меня? So in this case, I would have some other part of my body doing this transformation. But keep in mind that eventually, even that thing that I have just transformed becomes the same type of sound wave. And as you have observed, each time I want to learn a new language, I don't need a new pair of vocal cords, and I don't need a new brain. I can use the same kind of technology. Or I can take this to a slightly different path. For example, everything that I write here, I also use words, and I also generated them with the same brain that keeps creating these abstract ideas. But now, instead of taking this path, which then converts the idea into a word and then the word into a sound wave, I take another path which converts my message into some mechanical act that moves my muscles in such a way that you see text on the whiteboard. Again, if I want to write in English, I don't need to have another brain, and when I want to write in Russian, I don't have to get another brain. So you can see that I only have to change something down here, but the abstract parts are the same. And as you have seen, I'm using the same pair of muscles, regardless of which language I write. So you can conclude that the part here at the bottom is the same, and the part here on top is also the same, and only something in the middle changes. And you can take this analogy and extend it in many other ways. For example, have you played the game of pantomimes?
Which?
Pantomime. So somebody gives you a word, and you have to express it to a group of people without saying anything. All you can do is move your body and charades, you can call them in different ways, yeah. So that game takes advantage of the same kind of technology in the human body. You have your idea, you convert it into words, but then at the final stage of the transition, you don't convert it into sound waves and you don't convert it into mechanical motion, you convert it into another type of mechanical motion, which moves the body at a larger scale. So I wish to highlight that in this case, what happens in practice, the way our body ended up being designed, is that we can reuse multiple parts of our organism to achieve different effects. Now, people thought about it, and when they designed computer networks, they thought it would be a nice idea to take the same approach. But before I tell you that, let me make a few more things here, a few more comments. So the channel, in the case of voice communications, is the atmosphere. The signal are the sound waves. If we were in space, we wouldn't be able to use this method of communication because in space there is no atmosphere, so there is no medium for the sound waves to propagate. So if we were in space right now, you would see me, but you wouldn't hear anything because there is no channel for the signal to propagate. the signal is a very concrete thing. It can be expressed in physical or mathematical terms. For example, if we use a wire, then it's some kind of voltage pattern going through the wire. If it's a sound wave, then you can measure the amplitude and you can represent it as a mathematical function, like a sine function, for example. In the case of written text, again, the channel, so the signal are the photons that are reflected from the whiteboard, and then they hit your retina, and then they are transformed into some kind of electrical signal. That's how the brain works. And then it goes up the stack until it becomes another idea. And if I did a good job, the idea which I invested into my words will be exactly the same thing you interpreted. But as it is the case with human communications, for example, I don't know how it is in your countries, but in my country we have literature classes where they give us poems, and then we have to say what the author meant when they wrote this or that. I would often have disagreements with my teacher because what I think is different from what she thinks, and it may be different from what the author thought. But of course the teacher is always right, so it was always a problem for me. But now if my teacher were here, I could explain to her that, well, based on this, you cannot be sure that your interpretation is the same as the one of the author unless you talk to them and ask additional questions. Did you mean this when you said that? Or am I correct in assuming that you meant that when you wrote this? So this way, if there is a feedback connection, you can double check and you can make sure that this is the same as that. Which is why, while we are together, you are officially authorized to ask questions anytime to make sure that you understand what I'm telling you.
Cool.
Okay. Now there is something else which we have to define. So I will introduce the concept of a protocol. A protocol is a set of rules which we, as peers in a conversation, have to follow in order to communicate properly. There are different types of protocols. For example, if you see a lady, you have to take your hat off and then keep walking. Or if somebody says hello, you have to say hello back. Or in the US, people say, hi, how are you? Which, what they mean is just hi. They don't want to know how I am. It's just something they say automatically. But every now and then, I break the protocol and I actually tell them how I am doing. Sometimes they are completely surprised by my interventions. So this is what happens when you don't follow the same protocol. A protocol is a set of rules. Some of them are very formal, very well defined in mathematical terms or with some programming keywords which people can interpret without ambiguities. But some protocols are not so official, like hi versus hi, how are you? So, can somebody give me an example of a protocol?
HTTP.
Handshaking?
HTTPS.
HTTPS. Okay,
That
you
is-
are going very far away. I was looking for something more simple.
Following the rules of the government, like walking down the road when,
Traffic rules.
yeah, I mean traffic rules, that's
Mhm.
all.
Yeah.
Okay.
When you go to the airport, in the same sense, you have to follow a line,
Mhm.
wait in the queue.
So what happens when you break the protocol?
You
You
have
are-
some action being taken against you.
Mm-hmm.
The
So,
other person might misunderstand your action and commit something which was not
Mhm.
expected by you.
okay,
Yeah,
so
mistake over mistake.
usually the correct answer is it depends. Sometimes people can just misunderstand you. And for example, let's say in some countries, for example in Bulgaria, if I recall correctly, if you say yes, normally we do this, but in Bulgaria you do this and you say yes, I am coming to the meeting. So they break somebody's expectations. I can misinterpret that. For example, let's say some bus driver asks me, do you want to stop at this bus stop? And I say yes. And the bus driver may not stop the bus because he interpreted my message incorrectly. In another case, if you're in the airport and the guard person tells you to take your shoes off and you begin to recite a poem about democracy and freedom of wearing your shoes whenever the hell you want, you may get some kind of punishment for that. So unexpected things happen when you break protocols. Another example of a protocol I can give you is the handshake. Do you know where it comes from? Why do people shake hands? But you know that people shake hands, right?
Yeah.
And you shake them every now and then. So here is a bit of historical material. A long time ago, people always had weapons. You know, if you were a serious warrior, you were not a real person unless you had some kind of a sword. And the sword was always on the left side. So if you were attacked, you always needed your right hand prepared so you could do this. Ha! So when you extend your empty hand to someone, it means I don't have a sword here, so I am just hanging out with you, you know, user-friendly interactions. So basically, if you extend an empty right hand, it means I'm not going to attack. So that's where it comes from. But if you keep repeating it over the years without asking why it happens, you know, it ends up with people shaking hands all the time, but not knowing where it came from. So different things can happen with protocols. Another example I have to introduce here is the concept of an interface. So I will begin by asking you, what is an interface, in your opinion?
The interaction between the user and the
Some system.
system.
Okay, so if I have a system and a user, then where is the interface?
The front end.
Okay, so this part is the interface. And you are referring to some kind of graphical interfaces.
Not necessarily, but yeah.
Okay, what other types of interfaces?
More generally is like it's the layer where the interaction occurs between two objects, or between a human and a machine, or between a machine and a machine. So it's the layer in between.
Yeah.
All right, so the interface is something between two systems. It can be between a human and a computer. It could be between two computers, as he described. Do you know any programming languages?
Yeah.
Okay, so some people don't. Therefore, I will
A brief
provide.
description, please. A brief, because
Yeah.
time is slipping and we need good stuff from you.
Without basics, you cannot understand that. So in a function, in a programming language, there is such a thing as a function. For example, it gets some kind of a number at the input, and at the output it returns us some other number. And if you look what happens inside the function, you can see how this becomes that. But normally, in most cases, you can use a function without having to look how it works inside. So all you have to know is the interface. I know that if I give it, for example, an integer at the input, I will get another integer at the output. I don't care how it's implemented, but as long as the interface is preserved, I will be able to use this function without changing anything else in my system. There is also another interface, for example, one between a door and the wall. There is a hinge on which it rotates. I can build another hinge made from unobtainium. As long as it has the right size and it's at the right position of the door, I will be able to connect it to the wall without having to change the wall. So it's important to know that an interface, once you have defined it, you have to keep it constant. because there are other people and other systems which depend on this thing being always the same. Yeah. So let's take this concept and switch to network stacks. Engineers devised the following structure that has 7 layers. And they go
Are
like
you
this.
in the ISO layers?
Yeah, 7.
Yeah.
Okay.
Transmission.
Data link,
What's next?
transmission,
Transmission.
The-
I think it's
network.
Network.
Network, yeah.
But that is at higher level.
Network level.
Network and then
Transmission.
transmission.
PDNT, SPA.
Wow.
So security maybe, and presentation and application.
So you were mostly right. There was some guessing involved, but I can tell you a shortcut to how to memorize this easier. You have to remember the phrase, people do need to see Pamela Anderson.
Nice.
This
People do need to see
Yeah.
Pamela Anderson.
Actually, yeah, I have heard about it.
Yeah, not only that you heard about it, but you can use it in practice. So we have a bunch of layers, and the same rules apply to this construct. So on top we have something abstract.
Yes.
They are also clearly separated. Each of them has their own function. They do just that thing, but they do it very well. And I told you about recycling parts of technology. Absolutely the same thing happens here. So for example, at the physical layer, you're responsible for transforming the bits into electrical signals or sound waves or whatever type of communications you're using. Now, imagine that you have a program like Internet Explorer running on your computer. Internet Explorer is an application layer client for the HTTP protocol. And it doesn't matter if you have a wired network or if you use a wireless network or some other type of technology. Internet Explorer stays the same. All you have to do is change just this part of the component while everything else on top remains unchanged. In other words, we isolate the layers such that if you take one component out and replace it with another one, which was implemented in some different way, as long as we keep the same interface, everything else will continue to work. No module above or below the one you have changed will ever suspect that something changed, as long as you preserve the interface. What are your questions so far?
How do you change physical layer? And can you give examples as in what all you can change in physical layer and how?
So at the physical layer, you have some kind of a device, which at the input takes a binary word, like 111001, and transforms it into some physical property. In the case of a wired network connection, it would have to create some electrical signal. So this would be a 1, this would be a 0. On the other end, so this is a network stack. It's a stack because it's one thing on top of another. This is the same as this, in rough terms. On the other end, there is also a network stack. So the bottom layer here talks to the bottom layer there, and then it receives this electrical signal, then it does the backward transformation, and this becomes 101 something something. And then it's transmitted to the layer above, and then the layer above. And each layer we transform it the way we need, such that in the end you obtain the actual message. Now let me tell you a few more things about interactions between layers. So from the very beginning, let's say I have just my message. It was generated by something running at the application layer, the top layer of the stack. In order to hand it to the layer below, we usually take this and add some kind of a header to it. Sometimes it could be some information at the end. So let's say we have the header followed by the message. And then it goes down. And for the layer below, this whole thing is a message. It doesn't know about this, it doesn't care. It treats everything as
One message.
something, and then it adds its own thing. For example, it could add another header, let me mark it with H2, and it may also add something to the end. Let's call it a tail. And so the same thing happens until we reach the bottom of the stack. Now when it gets to the other end, at this point, it analyzes what it has received, and to do that, it needs to rely on the information in the headers in order to understand what to do next. So for example, in our case, when we communicate, we have, even though it's a tacit agreement, but we have agreed to use English. So whenever the signal reaches some part of your brain, it knows to decode these words
English.
as English words. Now, if I were speaking to you in a foreign language without telling you what it was, you would have a problem interpreting those words. But if I gave you a dictionary and told you, if I told you which language it is, then you would be able to go to the library, find a dictionary for that language, and then just follow the rules as defined in the protocol in order to understand what I'm telling you. So in this case, hypothetically, we could say that the agreement to use English is some kind of data in the header. So when you receive this bag of bits on the other end, you look in the very beginning. Let's say we have agreed to use the first 3 letters of each message indicate the code of the language in which that message was written. So for example, in our case, it would be ENG followed by the actual message. If I would use Russian,
So the
I would
header-
do this.
Header would contain the language and the message would be in the language.
Yeah.
Okay.
So in our hypothetical protocol, it's very simple. We use the first 3 characters as a way to encode the language, and then the rest is
Message.
the message itself.
Message itself.
Other protocols can have other types of rules. For example, you could have the first 3 letters indicate a language, for example, Romanian, followed by a number that indicates how long the message is. For example, 50. Followed by 50 characters, which would represent the message. So in this case, if I obey the rules of the protocol, and if I do this using an interface we have previously agreed to use, everything is great. Everybody is happy, and that is pretty much the way the world works. There are protocols and there are people who write clients and servers. A client is a program that connects to some other program that performs a service, and that one is called a server. The client and the server must use the same protocol so that they could agree on what's happening. Because if they don't use the same protocol, it's not going to be proper communication. What are your questions so far?
So when it goes from the physical layer of one system to the another physical layer of the another system.
Mhm.
And how does it go above to the application? Is there anything different, or it straight away goes to the application?
Well, it doesn't go right there.
Mhm.
What we illustrated here, so you take this, then you add a header, then you move it down, and then you add more stuff to it. The same thing happens on the other end, but
Yeah.
the other way around. So you
Kind of
remove the
reduction.
headers,
Mhm.
and at the end, when it reaches the top, you have just
There is
this.
a message.
And it is very important to indicate that the layer below doesn't care what's up there.
Mhm.
From its perspective, it's just a bunch of bits or bytes. It doesn't need to know what's in there. Which is why we can use the same transport layer protocol for sending pictures of cats, as well as for sending emails, as well as for sending voice messages or videos. So it doesn't need to know if it's text, video, or image. It doesn't care. It just sees things as a bunch of bytes. Somebody mentioned the HTTP protocol. Protocols are defined in formal documents. Usually, you can find most of them in such a thing as an RFC, request for comments. Basically, one person has an idea. Wouldn't it be great if we did this? And then they describe this in some kind of a formal way. They publish it on the internet, and the other groups of engineers and people and philosophers can read it and share their opinion about the protocol proposed by one person or another. And they can have multiple revisions of the same protocol, and then every now and then it happens so that the protocol is successful and everybody uses it. Usually you have a number. For example, HTTP is defined in RFC 2616. These documents are freely available on the internet. You can just Google it, click "I'm feeling lucky," and you will see exactly all the rules that you need to know in order to be able to talk to an HTTP server. So imagine that you're going to Google. You open that page in your browser. How does the browser tell the server that I want this page rather than some other page? How do you think?
It searches across directory. It must be having some kind of a directory of different websites. So it checks the keyword and it does it accordingly.
Mhm.
Mines the directory.
Okay, do we have other opinions?
It takes a domain name and goes to that domain.
Mm-hmm. Okay, something else you could add? Mhm. If you read this, you will find the answer to the question. And I am going to show you exactly what the browser is sending. When you connect to a server, you have to send a request. The way HTTP works is using a dialogue made of requests and responses to those requests. So if you look into that document, you will see that the client sends a request to the server. The server thinks about it, analyzes it, and then sends back a response, and then it breaks the connection. As simple as that. Now, all you have to do this is to know the format of the request. In our case, we invented a very simple protocol that said this.
Yeah.
What's happening in the case of HTTP? So you send them a keyword like get. It indicates I want this resource, and then you provide a path to the resource that you want to obtain. For example, index.html, And if you read the RFC attentively, you will see that I must every time I send something, my request has to contain several parameters. So the first one is this, it indicates the type of action I'm performing. Besides get, you may have heard about such a thing as a post. There is also options and many other ones. All of them are listed there. Then there is a space. Then there is a path to the resource which I want to get. So it's the address of the page on that server. Then in the end, you have a \r\n. Do you know what?
\RLN.
Two backslashes.
Okay.
\r,
Oh, okay, got it. Yeah.
do you know where this comes from?
Language. Is it program?
So there is such a thing as a table of characters.
ASCII.
Null,
ASCII.
null, it's a kind of, it symbolizes null. And
No.
It's new line.
Null is \0.
Symbolizes next line.
oh, next time.
Well, it could be someone who is late to the lecture. Hello, how can I help you? It is the building 4311. Yeah, and come up to the 4th floor. We're on 416. The building is locked.
For second life.
All right.
Alex,
I'll go.
Somebody will pick you up. Just a moment, okay?
So I mean,
So you write this. Oh yeah, I was telling you about this. \r/n. So this indicates a new line.
yeah.
You probably noticed in your programming examples that you usually write just \n.
Backslash n.
Yeah, they can see.
And then where the hell does
Next
\r come from? Do you know?